Hey Hux, so finally we're at the point where we can talk about how do we know what stars are made of. And so it all comes down to this thing called atomic emission spectra. And so we're going to look at how different elements give off different types of light. Okay. And so I will explain why elements have unique atomic emission spectra and can relate the spectra to the patterns of electrons and changes in their energy. So electrons move inside the atom. Okay. So basically, they start off in the ground state, right? And the ground state of an atom is when the electrons are at the lowest possible energy level that they can be. So, for example, here's neon, and neon in its ground state has two in its first shell, and then its second shell has 8 electrons, right? So basically, those two levels are full. But it's possible for those electrons to get excited and jump into another level. So when energy gets added to an electron, right, the electrons get excited. And it's a lot like sugaring up a kid, right? And this is called the excited state of an atom. Okay. During the excited state, the electron jumps up to another orbital. And we're usually looking at those valence electrons that are doing that, but it is possible for the inner ones to do it too. Okay. And so, for example, in this atom that we're looking at here, it has 2 electrons, and it started out in the first, or that s orbital. It got excited, so it jumped up, and now it's in that second energy level orbital, right? And so if we look at it in another way, we could say, here's ground level, right? Here's where we're at ground level for helium. Our electron's going to get excited, and it's going to jump up, okay, to the 2s orbital right here, okay? And so it's excited. It could have been so excited that it jumped into the 3s, right? It just depends on how much energy the electron has. Okay. Since electrons prefer lower energy levels, the electron is then going to fall back to the ground state. And in that case, it has to give off or emit energy, which in this case is in the form of a photon. And the photons are like these little packets of light. Okay. So somehow energy comes in and gets this electron all excited, and it jumps up to another shell, right? And then it prefers to be in its ground state, so then it jumps back. When it jumps back, it has to give off or emit energy, and that energy is in the form of light. And so the color of the light emitted by the photon depends on the amount of energy that the photon carries, right? So it can happen anywhere in this spectrum, right? It's called the electromagnetic spectrum. And it goes all the way from gamma rays all the way up to radio waves. And so if we're looking in the visible part of the spectrum, you would start at blue or violet. And then as you move up, the reds are lower energy, right? So you're going to get blues when it's giving off a lot of energy, and you're going to get reds when it's not as much energy, much lower frequency. Okay. And so that is how we end up with these colors coming from these stars. And by looking at the colors that we get, or the wavelengths that we get, we can look at what these stars are made of. And so at the beginning, I was showing you the spectra for the first couple of elements. So you have hydrogen and helium. So hydrogen gives off some purples, blues, and some reds. Helium brings in some greens and yellows. Neon, which is the next um, uh, most stable atom, has lots more in like the reds and oranges and greens, kind of in the center. Sodium only has these three lines where it's, kind of a cyan or a off blue green, and then you have, your yellows and your yellow greens. And then mercury, we all know what mercury is. Mercury has the the purples, blues. It kind of has a little bit of everything in it, right? It's a matter of how much of the blackness is in between, right? That determines which element it is. Okay, so simple, very simplistic way of looking at it. There's a lot more to it, but now you should be able to explain why elements have unique atomic emission spectra, and then be able to relate that back to some of the patterns that the electrons give.